You know, our oceans are basically superhighways, just packed with these enormous ships. But here's the crazy part. There are no lines painted on the water, no stop signs, no traffic lights. So you've got to wonder, how do we keep everything from turning into total chaos?
Seriously, just picture the craziest traffic jam you've ever been stuck in. Now, just erase all the lanes, rip out the signs, turn off the lights. That's what we're talking about on our busiest waterways. It's this swirling, unpredictable mess of massive cargo ships, super-fast ferries, and tiny boats, all fighting for the same patch of water.
I mean, that sounds like a total recipe for disaster, right? So it really begs the question, how on earth do we keep these busy routes from becoming scenes of constant catastrophe?
Well, the answer is in rooms that look a lot like this. This right here, this is the nerve center of what's called a vessel traffic service, or VTS for short. The easiest way to think about it, it's basically air traffic control, but for ships. All right, let's really dig into how this whole thing works.
Okay, first up, the unseen traffic cops. I love that description, because that's really what they are. These are the folks watching over our waterways, kind of like invisible guardians, making sure everything stays in order.
So what exactly is VTS anyway? Well, in a nutshell, it's a system run from the shore that keeps an eye on and actively manages all the ship traffic out there. The mission sounds pretty simple, right? Enhance safety and efficiency, but man, it is absolutely critical to making sure everyone and everything gets where it's going in one piece.
All right, on to Section 2, Mapping the Maritime Highway. It makes sense, doesn't it? Before you can manage the traffic, you have to know the road. And for VTS to really work, it all starts with a super deep understanding of the waterway itself, both the physical layout and how it's actually used day to day.
So how do you actually create order on the open water? Well, check this out. They use something called a traffic separation scheme, or TSS, and the idea is actually pretty brilliant in its simplicity. You basically just create designated lanes, one for inbound traffic, one for outbound, just like a highway. It's all about organizing that flow and, keeping these massive ships from bumping into each other.
But hey, it's not just about side-to-side traffic. VTS operators are, and I mean this, obsessed with what's going on underneath the ships. They call it under-keel clearance, and it's exactly what it sounds like. That super important safety gap between the bottom of the ship, the keel, and the seabed. If that margin gets too small, bam, you've got a ship stuck on the bottom. It's a number they are watching like a hawk all the time.
And this is where it all comes together beautifully. What you're looking at is a nautical chart. This is the VTS operator's map, their whole world. You can see the shipping lanes we just talked about, right? And you can see all the different water depths. That's what tells them about the underkeel clearance, plus all the buoys and markers. It's literally the blueprint for getting a ship through safely.
Next up, let's talk about the VTS operator's playbook. So we've seen their map, right? But how do they actually use it to direct all this traffic? Well, it's not about just sitting back and watching dots on a screen. No way. It's all about being proactive, using a really specific set of rules and tools.
And this right here is the heart of their whole strategy. It's this constant 5-step cycle for managing risk. Step 1, identify any possible hazards. Step 2, assess how likely it is that something bad will happen. 3, evaluate just how bad the consequences would be. Then, based on all that, step 4 is to implement ways to reduce that risk. And finally, number 5, they're always reviewing how well their plan worked. It just goes on, this perpetual loop of making things safer.
And you know what? None of this would work without one key ingredient: communication. There's this constant, absolutely vital link between the operator on shore and the crew on the ship's bridge. The VTS operator has that big picture bird's eye view, and they feed that critical info to the crew so the crew can make the right calls on board. So just how far ahead are these folks thinking? Well, for short-term planning, this is the magic window: 4 to 6 hours. They're looking that far into the future, figuring out the perfect order for ships to arrive and depart, all to keep the flow of traffic smooth and predictable. Now, when things get tight, like in a narrow channel or coming into a port, that planning gets even more detailed. We're talking about enforcing a 15 to 30-minute gap between these huge ships just to make sure everyone has enough space. And that's the key thing to remember. None of this is happening by chance. It's not reactive. It's like a highly choreographed ballet, just with giant multi-ton ships.
Okay, new section, responding to danger. Because, all the planning in the world is great, but what happens when something unexpected goes wrong? This is the moment where VTS operators really earn their keep.
These operators are trained to have a sixth sense for trouble, to spot the earliest warning signs. You know, if two ships are on a collision course, they see it. If a vessel is starting to drift off track toward shallow water, they see that too. They are constantly scanning for any of these little telltale signs that a situation is about to get dangerous.
All right, let's play out a scenario so you can see what I mean. Picture this, a massive bulk carrier, right in the middle of a busy channel. Radio's in. Their steering has failed. The crew has lost control of the ship.
And things go from bad to worse fast. The ship is now just drifting. And all that momentum is pushing it straight toward a shipping lane that's packed with other vessels. The clock is absolutely ticking.
This is where that playbook we talked about snaps right into action. The VTS response isn't panicked. It's calm, it's methodical. First thing, they get on the radio, request more info to understand exactly what's happening. Then boom, a warning goes out to all the other ships in the area. They start giving advice to the crew on the disabled vessel. They quickly set up an exclusion zone around the ship to steer everyone else clear. And finally, they're coordinating with tugboats to get the situation back under control. They really are the calm in the middle of the storm.
So where does all this go from here? Let's talk about the future of VTS. What's next for these guardians of the sea? Because, as you can imagine, technology is moving at lightning speed, and it's totally reshaping what's possible for maritime safety.
I mean, the future is basically already here. We're talking about AI that can predict a potential collision before a human operator even sees the risk. We've got incredible satellite surveillance that gives operators this almost godlike view of everything happening on the water. E-navigation is making the conversation between ship and shore totally seamless. And get this, as we move toward fully autonomous uncrewed ships, VTS is going to be like the conductor of a robotic orchestra out there on the ocean.
But, and this is so important, here's the main takeaway. It really all comes down to this quote: "Despite technological advances, the human element remains essential." Look, all that amazing tech is just a tool. At the end of the day, it's the human operator's judgment, their experience, and their ability to communicate that actually stops a disaster from happening. The tech helps, for sure, but it doesn't replace the person in the chair.
And that really leaves us with a pretty fascinating question to chew on, doesn't it? As technology gets more and more autonomous, what's the right balance? How much do we rely on human expertise, and how much do we hand over to artificial intelligence when the stakes are this high? That's definitely something to think about.